everyone, myself K.Priyadharshini. I am working as assistant professor in Department of Computer Science and Engineering. Now I take the topic in a quick start. The small example to understand the quick start. The group of students arrange the teachers are asked to arrange the students in a height order. So there are two ways to arrange the students. One, the teachers call the students and go and sit here and go and sit here and go and sit here. So the teacher shows the place of the students. And another way is that the students are arranged themselves because he know the height of the students, and he call the friends, go and sit here because you are the smaller in the classroom, you are the height in the classroom, you go and sit place and go and sit there. So it is the smallest in the class. So it is the example. So it is the smallest in the class, so we come in front side. So it is the height in the class, so we come in the last one. So remaining students are arranged himself. So that is the way the quick start will work. He identified that correct sorted position. So the sorted position is identified correctly. So that is the way the quick start will work, and we see for that example how the quick start will work. We can take some numbers and how the quick start will work. You know that the quick start will work on that divide and conquer methodology. So what is the divide and conquer methodology? So we can divide the problem into subproblems. Each subproblem can be solved separately. So that is the way the quick start will work. Now we can take the sum of the numbers, how the quick start will work. So 10. I tell that one example, which is the fastest way to arrange the students in ascending order. It is the second one, because that we can arrange themselves, so we know that height of the place. That is the method we can apply for the quick start. So the element in the sorted position first identified. The sorted position element, the left hand side is a smaller one and right hand side is a greater one. So we can work for the sum of the example, that is we can take it as a number, how the quick start will work. So the first value we can take it as a pivot. The pivot is equal to 1, and low is equal to, that is the lowest position, we can take it as the first, and highest position we can take it as the infinity. It is the end of the string, we can take it as the infinity, other we can take it as a null character. Okay. So now I is equal to low and j is equal to high. Okay. So the I is search for the element, it is a greater than the pivot, and j is search for the element, it is a smaller than the pivot. So if that greater element is found and smaller element is found, so we can exchange for the two elements. We can swapping is done. Okay. So when you stop that, the I is stopped when you reach the end of that one, that is h, and the j is stopped when it is reached for the low. So now we can check for that. The I is placed in, the I is incremented. We can search for the greater element. So now I is incremented is a 16. So the 16 is greater than 10. So now I can stop. Now j is decremented. Is search for the element is smaller than the pivot. So it is smaller than the pivot. We can stop. I can swap these two elements. 10, 5, 8, 12, 15, 6, 3, 9, 16, infinity. Now I is incremented. So 8 is not smaller than 10. And we can search for the greater element until I is incremented. So again I is incremented. Okay. So the 12 is greater than 10. I can stop. And now j is decremented. The j is go for the 9. is 9 is less than 10. So I can swap that ing. So the I is placed in the 12 and j is placed in the 9. So I can swap these two numbers. In a quick sort, first we done for the partition, now I done for the partition. Okay, so it is in a I and it is in a J. Now I is incremented. Okay, so we find out that the greater value, so we can stop, and J is decremented. So you find out the smaller value, so we can stop. We can swap these two values. So now I is incremented. So it is a smaller value. So again I is incremented. If I know the greater value, we can stop here. So now j is decremented. So if I found out the smaller value here, it is 6. So that is that we cannot add for the swap because I crossed j. So what is the now we identify the position of the j. It is that 6. It is a pivot element position. So we can swap that element to that pivot. So we can, after the swapping, the 10 will be go in a place 6 and 6 will go for that 10. So the partition is done. So we identify the correct position of the 10. So we check for that element. The left side of the element for the 10 is smallest and greater than element is presented on the right side one. Okay. So it is a partition built done. So again we can done for the quick sort in the remaining rest of the elements, that is 6 by 8 9 3 and 15 12 16. So we can sort out the element based on that algorithm. Okay. Position and anti-position. If I, that is low, less than high, we done for the partition. J is equal to partition of L comma H. So how the partition will done? So the quick sort is performed. First load to J value and the quick sort the left side one and right side high to, that is J plus 1 to high value. So this is the algorithm for the quick sort. So we can write before we write the code for the partition again, and then we can write for the algorithm for the quick sort. Okay. Now we can see for that best case and average case and worst case efficiency of the quick sort. So T of n is equal to 2T of n by 2 plus n. Okay. So what is the 2T of n by 2 is that? So here that we can divide that array in a two subarrays. One it is the n by 2 array and another is the n by 2. Okay. We can perform the two subarrays. So T of, that is that time taken for that left side of the array and time taken to for the right side of the array. That is 2t of n by 2. So n by 2 plus n by 2, that is 2t of n by 2, and n is the number of comparison required for that arrays. Okay, that is n. So now we can take it for that n is equal to n by 2. So again the list, the n number, it is divided into n by 2. So t of n is equal to 2t of n by 4. We can substitute n is equal to n by 2 plus n by 2. It is the equation number 1 and it is the equation number 2. So we can substitute 2 in 1. So t of n is equal to 2 of 2t of n by 4 plus n by 2 plus n. T of n is equal to 4t of n by 4 plus 2n by 2, so n plus n. It is equation number 4t of n by 4 plus 2n. It is equation number 3. Stop it. Now n is equal to n by 4. So t of n by 4 is equal to 2t of n by 8 plus n by 4. This is equation number 4. Now we substitute 4 in 3. Okay. So t of n is equal to 4 2t of n by 2 plus n by 4 plus 2n. So 8t of n by 8 plus n plus 2n. This is equation number 5. That is 8t of n by 8 plus 8n. Okay. So after some time, we apply for that n by 8 and n by something. So after the some time, so we can write it as so 2 power 3 of t of n divided by 2 power 3 plus 3n. So the 8 in terms we can write it as a 2 power 3 and here the 8 will be written as a 2 power 3. So we can take it as that k times. So 2 power k t of n divided by 2 power k plus the constant we take as k into n. Okay. So n is equal to 2 power k. Okay. So we can solve it separately. 2 power k. We can apply log for both sides. Log n is equal to k log 2. Okay. So now what is the k value? So log 2, the base 2, it is the value is 1. So the k value is equal to log n. So So n is equal to 2 power k. So m g of n by n plus k into n. Okay. So the n will be cancelled. N into d of 1 plus k into n. So what is the g of 1 value? If n is equal to 1, so the input size n is equal to 1. So now that at least one comparison will be made. So n is equal to 1, g of 1 is equal to 1. So n plus k into n. What is the k value? It is a log n. So n plus log n into n. So now we can write it as n plus n log n. The time complexity of best and average case is big O of n log n for quick sort. Now we can see for that is average case, worst case. Worst case. In a worst case, the number is already in the ascending order. Suppose 1, 2, 3, 4, 5. We can check for that n number of comparison. With that for the partition, first we can take it as the first element and we can check up to 1, 2, 3, 5. And again we can take it as the second element and check for that 5, up to 5. And next we can take it as the third element and check for that up to 5. So here we can make it as n comparison. Here n minus 1 comparison, here n minus 2 comparison. So up to we can check for the single number 1 plus 2 plus up to n is equal to. So we can make 1 plus 2 plus we can make for n comparison. We write the formula n into n plus 1 divided by 2. So n square by 2 plus n by 2. So the big O of n square, it is a time complexity for the quick sort in the worst case.